Bonjour, je suis not manly, et ici le voyage d'espace je ne sais quoi. And after a bit of a break, we finally venture into unknown territory, out to Edna, the first dwarf planet of the system, 520 kilometers diameter on average, surface gravity 0.08, and one satellite, another asteroid named DAC. Orbit speed here is pretty high here. A day only lasts 3 hours in spite of a year lasting just under 4 years, and that's a pretty impressive inclination too at about 3 degrees. Delta V to get out here, you require 2.4 kilometers per second. To capture you need about 2.2 kilometers per second, but landing is pretty cheap at a mere 370 meters per second thanks to that high spin, at least as long as you rotate in prograde, or orbit in prograde. It's a superb challenge of your mission planning skills. If you are an expert, try getting out to Edna. It's pretty easy landing and ascending as well if you can get out here because of that spin. The problem is there's only a few biomes out here, and that spin rate will make landing tall craft pretty difficult. And it's, they could have done a better science multiplier because of how hard it is to get out here. Anyway, before we can get out to Edna, we start to launch our first of 3 relay satellites. We're out here at the orbits between Duna and Edna here, and we're going to get our first of 3 relays out there. Each satellite has a pretty large fuel tank with just over 2 kilometers per second so that we can circularize our orbit above the Sun and get an orbit period of just under 3 years. I am shooting for 2 years and 322 days, which will take a while, so let's skip ahead here a little bit. There we go. Let's see, 321, 322, oh, a little high there. Let's see if we can dial that back a little bit. There we go. Just under by a few seconds. We'll take that. And this is one of 3 ready to receive signals from this craft, the main mission craft for Edna. It only consists of a single lander, which is also a rover. We've got a small scanning arm on there, not to get any serious science from the scanning arm, but to be able to figure out what any objects have to say if we find them. Now here's a neat thing. If you have a transfer window planner, you can just plug in the delta V numbers right into the maneuver editor in Kerbal Space Program 1.7 and later. And all you gotta do then is worry about the timing of your ejection. So there we go. We'll just plug that in there. 2.3 kilometers per second out, and then anti-normal of just under 350. And then we have our ejection, and all we gotta do is plan the timing. Not bad at all. So a good use for transfer window planner. I'll go for a good close approach first because I'll be able to do my adjustments later on. Then I shrink my orbit back because I need to wind up the orbit first, and I've only got 1.5 kilometers per second on the chemical rocket stage. We're doing the same thing we've done before to try to save on nuclear delta V, which is use a chemical rocket stage to get as high up as we can, and then we use Kerbin as a slingshot to eject out the rest of the way. Just as we've done before for Moho, for Eve, and for Duna. And the ejection then becomes a mere kilometer per second. But that insertion, oh my goodness, 1.9 kilometers per second and change. It's going to take a bit to capture over there. In the meantime, we're sending a refueler craft out to Dres. What we're going to do is do both locations in one mission, and we'll send a refueler out to Dres for the Edna main mission craft to catch up to. And then they'll be able to come back to Kerbin in one piece. 2.2 kilometers per second to capture at Dres. Here we go. A year and a half later, we approach Edna. Now, one thing I was not expecting to find at Edna was an anomaly. Now, I figured that the the new planets wouldn't have had any configuration for anomalies, but hey, we'll look for that. We'll see what we find out there. In the meantime, Roberta Lynn Kerman is out here doing high space science, and look at that. We can finally tell KSP, hey, we know if we remove the data, we're going to make the instrument inoperable, but that's okay, we're using a scientist. So hey, you can tell it that. Here comes the insertion, a good 7.5 minute burn. And then we just keep burning, and we keep burning, and we keep burning some more, and we keep burning some more. And there we go, some nice glamour shots of the surface of Edna, including a tall peak there that wasn't really that tall, but hey, that's okay. And there we go, finally captured there. We do an orbital plane change to line up with DAC before finally circularizing our orbit above the surface of Edna, because we're going to head out to DAC when we're done here. Look at that little spot with the 3 white spots there, that crater. We'll go visit that when we're exploring the surface. Here comes our lander. It has a single RTG on there, along with some solar panels for supplemental power. We're still going to use Bon Voyage to find our way around there. I put on some Werner RCS thrusters to assist with docking, but maybe I didn't need to do that, and I'll show you why later. And we're going to board Julie aboard the lander/rover, and then we're going to send Roberta Lynn Kerman aboard there. I toyed with the idea of landing the main mission craft on the surface of Edna as well, but we kind of need that Delta V to safely get to Dres, and it turned out landing that thing was not very practical anyway. Edna spins so fast that tall craft really have a problem staying upright, and we just can't leave that thing on the surface lying flat. So we'll just land the rover, and then we'll bring the rover back. We will be able to reuse the rover on the surface of Dres, and we will be able to land the main mission craft on Dres. So we'll be able to pick these guys up safe. At least that is the plan. We'll see how well that plan goes when we get these guys out there. In the meantime, Roberta and Julie Kerman are landing on the surface. Landing is pretty easy again. And there we go. There, look at that. Gotta start things off with a bang, right? Touchdown on the surface of Edna. Here goes Roberta Lynn Kerman with that workflow that we know all so well, starting with the planting of the flag. Our first on a dwarf planet. And there we go. Edna, speedy place. After that, it's the same workflow that we know and understand so well. At least I hope we do. Again, we can take experiments out of the experiment storage unit, put them back, and that'll free up slots for surface samples, rock samples, and whatnot. Careful, don't tip the rover over. There's that RTG on there, and back to the experiment storage unit. Not bad at all. We head out to where the anomaly is supposed to be, and I don't see it yet, but I am seeing some little white rocks out here. That kind of looks like it could be similar to the moonstone we've seen. Ah, there we go. There's the object. It's the only thing that stands out amongst all of the other terrain scatters, so hey, this has to be it. I didn't see any monoliths or random monoliths or anything, but we do have this. Let's go check this thing out, see if we can scan it. Oh, careful, careful. There we go. Let's retract that so we don't back into it. Scan Dres meteorite? What is a Dres meteorite doing on the surface of Edna? Yeah. I would say Dres has a violent impact, or has a violent past, considering this isn't even Dres. Okay. Not to mention that this is Moonstone? What's Moonstone doing on the surface of Edna? Oh well, I suppose you can only work with what you've got in the stock game, right? There we go, Moonstone analysis. We've seen this before. Those papers aren't going to wait themselves, but they are worth twice as much science. We do get up to the North Pole. There are only 4 biomes up here, but the poles is a biome. Yep, that's the North Pole. I'm not seeing any terrain fissures or anything unusual, so hey, this could be okay. Here's one of those craters that has some of the white spots on them, with rational resources, there's probably some pretty interesting stuff underneath these particular craters. We didn't have any resource kit with us though, but that's okay. Look at that. Oh, there's the South Pole. Nothing unusual there either. Yeah, no, if you thought stock Dres was boring, I think Edna here is pretty boring, aside from that really high spin. Anyway, we're going to catch up with Chris's craft, but it's more important that we get that inclination straight first. We can worry about other stuff later on. And there we go. We'll fix up our inclination, and then we'll worry about catching up with Chris once we are safely in orbit. Yeah, we can't do maneuver nodes right now because we're not in contact with the Space Center, but that's okay. We're also not in contact with Chris, but again, we can figure that out. All we need to do is make sure we get safely into orbit, and we should be okay. Come on, a little more. And there we go. Safely in orbit. And barring anything else, well, we'll just brute force this. We'll line up that intersect 2 until it's not almost. And there we go. Rendezvousing was pretty easy. Nothing really crazy here. We're going to get the ladies out of this rover before we redock it with the main mission craft. Not bad at all. There we go. Roberta brings her batch of science along, and then Julie will bring the other batch of science along, and then we'll redock this. Not too bad. You know, for as much effort as it took to get out here, doesn't seem like much of a reward. I don't know, they could have put craters out here or something, or maybe those white spots could have been their own biome. I don't know. Or at least put a random monolith out here. It is possible to do that on custom worlds. But hey, we'll dock the rover back up here, and then we'll head out to DAC. And look at that, I didn't even need to use those RCS thrusters. Well, we're gonna head out to DAC in the next episode. Until then, I'm not manly. Fly safe.